July. So today we will be doing costs. Again, cost is an important aspect of production behavior. Now generally in economics we use a different concept of cost. At a higher level you can see that cost itself will be two types. One is implicit cost and the second one is explicit cost. Explicit cost is also known as accounting cost. Whenever we are talking about cost, we include both implicit and explicit cost. By explicit cost, we means the cost that is incurred on raw materials, labor, capital. For example, for raw materials, you will be purchasing raw material. You will be also giving wages in return to labor. Then for capital, you need to pay interest. So all these costs that is incurred on paper will be called explicit cost. But in reality, it could also be the case that a particular entrepreneur or a particular producer might be using his own labor or his own resource. So how to calculate that is an important question. For example, me being a teacher, I might be having two options. First is I might be working on as a teacher, so I will be getting say 5,000, say 50,000, whatever, 50,000 rupees. But in that place, suppose I am starting my own business, and for that I might be employing labor and some raw materials. But I am using my own labor and at the same time my own expertise, or you can say the place where my factory is installed. So over here I will be paying explicit cost, but at the same time there is cost for my own labor and resources. Now that will be implicit cost. So explicit cost itself is, you can say, cost of raw materials and simply return on labor and capital, etc. While implicit cost will be cost of labor oblique materials that an individual utilizes or utilize in production. Production for which there is no return, because the factor is owned by the individual itself. So over here we use another concept which is called opportunity cost. We use opportunity cost to estimate the value of such factors which is owned by that individual only, for which he is not getting any return. Then we use, in economics, we use this concept called opportunity cost. I hope in the earlier classes you have studied that opportunity cost determines the cost of next best alternative. Again, it is next best alternative. For example, take the case of a field. Suppose I have a field, so I might be having certain kind of options. Option A might be I am growing wheat, and say the productivity of wheat or the revenue that is generated is 10,000 rupees. Or I might be having an option B of growing, showing rise, then the revenue of which is 8,000 rupees. Or say there is C, the other option, I can use it to grow maize or corn, and I might be getting 6,000. Now these are the options. Now how to calculate opportunity cost? Opportunity cost represent the cost of next best alternative. So what are the alternatives, possible alternatives? I can grow wheat, I can grow rice, I can grow maize. Finally, I've chosen that I have grown wheat. Now what is the opportunity cost? In order to grow wheat worth rupees 10,000, I am sacrificing rice worth 8,000 rupees. So this 8,000 rupees is the opportunity cost for this. Similarly, I am taking the earlier case where I am working. If I am working, I will be getting 50,000 rupees. But in place of work, I have choose to start my own business or production. So I am getting something. But now how to estimate that? For that estimation, I am using again the concept of opportunity cost, where my cost is now 50,000 rupees, which I might have gained if I've worked in place of doing my own production. So similarly now, whenever we talk about cost in economics, we use both the concept. That is, cost over here represents both implicit cost and explicit cost. Now like production, again, while understanding the concept of cost, we use the time factor. So that means again we have something called short run and long run. As we have seen earlier, that short run is basically a period when at least some of the factors are constant. That means we can only increase by your production by employing more of those variable factors. Similarly, now here also whenever we talk about cost, cost can also, like total cost in the short run, basically your total cost can be also divided into two components. One is your total fixed cost and the second one is your total variable cost. Now as far as fixed costs are concerned, it includes all those costs which are fixed. That means even when you have zero production, or whether it be 100 units of production, your cost will be same. Now it includes cost of your factory, the rent, similarly the cost that is incurred on machines and tools that you are employing, and the cost of your permanent employees. All this will be your total fixed cost. Total fixed cost, even when your production is zero, you have to incur those costs. Second is your variable cost, total variable cost. It includes all those costs which increases with production. For example, it could be cost of your raw materials that you are employing. Similarly, it could be cost of your labor that you employ on daily basis, and vice versa. So as a whole, we have two components of cost in the short run. Now look at this graph. This graph shows those total cost curves. First is this, your total fixed cost. Now again, it's fixed. Even when you have zero output, one output, Q1 output, it will be fixed. So it's completely a horizontal line, straight horizontal line along your x-axis. And second is your variable cost. Variable costs are those costs which vary or which increase with production. So initially when you have zero output, you have only fixed cost but not variable cost. Then as you increase your production, your variable cost also increase. Now as far as its shape is concerned, initially it increases at diminishing rate. After that it will be a constant, but it will increase at a constant slope, and then eventually it will increase at an increasing rate. Now if I vertically add total fixed cost with your total variable cost, you will be getting this total cost curve. For example, at Q1, at this point, this will be your total fixed cost, and this will be your already your total variable cost is given. I'm simply vertically adding this component. So this component is nothing but you are at each point it's total fixed cost. So when we vertically add your total fixed cost with total variable cost, you get this total cost curve, which has an upward sloping. Now the second component is your average cost. Now what is average cost? Average cost is simply like total cost divided by number of products, Q. So this will be your average cost. For example, now you have one is average fixed cost. What will be average fixed cost? It will be simply total fixed cost divided by Q, where your Q stands for number of outputs that you produce. And similarly, you have AVC. AVC stands for average variable cost, which is nothing but your total variable cost divided by number of quantity produced. Now again on this graph we have figure 3.4, which shows the shape of your average fixed cost. Now as far as average fixed cost is concerned, the shape will be like rectangular hyperbola, about which we studied earlier also in our earlier classes. Now what will be the property of this average fixed cost curve, the rectangular hyperbola, is that at every point, whether it be C or any hypothetical point C, if I draw a rectangle, it will give you an area which will be equal to your total fixed cost. If you remember in the last when we studied expenditure, we also had similar kind of concept where I said that, where I put the equation that P into Q will be equal to E, where E stands for your expenditure. Now here also P into Q will be equal to E, while E will be here total fixed cost. So whether you will be here or you will be here, every rectangle will give you similar area, and that will be your total fixed cost. Now here also as far as average variable cost also, at point Q naught, at point B, we are getting this area. Now what this area represents? This area represents your total variable cost, but at Q naught level of output. Similarly, when you are here, then it will give you another rectangle which might be different from it. It will give you the total variable cost at hypothetically say Q1 unit of output. Now again, when we look at the shape of average variable cost, it will be like a U shape. Initially your average variable cost will decrease, and after some point it will increase. So it's like a U shape. Now the next is your shape of marginal cost and average cost curve. Marginal cost, the definition is simply like how much will be the change in your total cost. We can also use here total cost, or in some case your total variable cost also, because since your total fixed cost is constant, how much will be the addition to your total cost when you increase your output by 1 unit. That is what your marginal cost is. Now what will be the shape of marginal cost and average cost curve? Again, your average cost is simply like addition of average variable cost plus average fixed cost. Now the shape of marginal cost is generally U-shaped, and the shape of average cost is also U-shaped. But there are some properties also, but for this again I am looking at the earlier concept that we have studied during production, where we studied two curves, marginal productivity curve, MP curve, and AP curve. Generally the thing is both the two curves are mirror image of each other. Mirror image means when your marginal productivity curve is increasing, your marginal cost curve is decreasing. Now as per definition, marginal productivity is how much will be the productivity of an additional factor. and your marginal cost will be how much will be the cost of an extra unit of input. Here variable input, so it's labor. So whenever you have an increasing productivity, your cost will also gradually, marginal cost will also gradually come down, since both the two are inverted image or mirror image of each other. So both the two have, it's an inverted U shape and eventually it's a U shape. The second is your average cost curve. Now what is average? Average is simply your summation of total marginal cost divided by Q. So average will also follow the same trend. That means when your marginal cost is decreasing, your average cost is also decreasing, but the intensity will be much lower, and after some point, after this point, it will start increasing. But your average cost will still decrease, but eventually your average cost will cut your marginal cost at a point where your average cost will be minimum. Beyond that, your average cost will also follow the trend of marginal cost, so it's increasing and therefore it will also increase. But initially it will be marginal cost that will increase, and later on average cost that will increase. So anyhow it will cut at the minimum point. After that your average cost will also increase, and so will be your marginal cost. Similar will be the case of average productivity. Initially your average productivity will increase since your marginal productivity is also increased. But after some point your marginal productivity will start falling, but average productivity will still increase up to some point where it intersects marginal productivity curve, where it will be at its maximum value. After that your average productivity curve will also decrease. Now we will be looking at this particular figure which represents your short run cost. It's very important from examination point of view. Now it will give you the overall picture of cost. Here you have short run marginal cost, which will be an upward sloping U-shaped curve. Then you have an average variable cost. Now if I add average fixed cost to average variable cost, I will be getting your average short run average cost. So the shape of average fixed cost, again if I am drawing here, it will be like this. That's your average fixed cost. So initially the difference between the two is much higher, because to AVC I'm just adding this, so it's much higher, but eventually the value of AFC keeps on decreasing. So here the distance between average cost and average variable cost is much less. So it's simply average variable cost plus average fixed cost. I am getting short run average cost. Here the value of average fixed cost is much higher, so it has the distance is very much higher. Again it will be intersecting initially at average variable cost at that particular point where it's minimum. That means beyond Q1 your average variable cost is decreasing. After Q1 your average variable cost is increasing. Similar is the case with short run average cost. Before Q2 your average cost is decreasing, and after that your average cost is, after Q2 your average cost is increasing. So the last major topic is your long run cost. Again in production you have studied return to factor that describes your short run phenomena, and return to scale that represents your long run phenomena. Both the two concepts are related. Now again, what is long run? Again as a recap I can say that long run represents that particular epoch or time period when all your variables are, all your factors are variable. That means you can increase the size of your plant, you can do whatever you want. That means you have only variable cost and there is no fixed cost. So the total cost is simply consists of variable cost. It will be similarly TVC. Here no cost is your fixed. That means you can increase the size of your plant, you can employ more machines, you are provided with substantial independence in this regard. Now here if I look at average cost is simply your total cost divided by Q. Now Q represents your total output. And similarly, when I calculate marginal cost, that is your total cost at Q1 minus total cost at Q naught. How much is the change in your total cost when I'm increasing your output by 1 unit? Now I'm coming to this curve which represents the shapes of your long run cost. Now here you have only one component as long run average cost. Since there is no variable cost or fixed cost, so only we have one cost. The shape is like initially from initial point to M, this cost curve is decreasing, and after that it is constant for a moment, and then this cost curve will increasing. And as far as marginal cost curve is concerned, again it will be an inverted U shape. The other important property is that this marginal cost curve will always cut your average cost curve at its minimum possible value. Second important thing is, initially from this point to M, your cost is decreasing. Cost is decreasing. The reason is that you are having an increasing return to scale, or IRS, and here to a brief moment you will be having a constant return to scale. That's why your cost is also constant. After that your cost is increasing. It represents that you are having a decreasing return to scale. That's why your cost is increasing, and this will be your marginal cost. The two intersect at M, where this point will be the point where you are having cost minimization. So from this is the last major topic. Again, as a recap, we can